Did it ask your question again, or did I just?
The delta F's, I just want to know how they all got to where they are.
All right, so I know that my initial frequency plus some change in frequency is going to get me my final. I know that my initial frequency is more than my final frequency, so even though I have plus delta F here, I know delta F is going to be a negative number. Then I took I plugged in this expression here in for that, which gets me this.
Right.
It's a binomial squared.
Right. Okay, that's it.
That's
it.
Okay.
That's it. Thank you.
And I know you said that's it, I'm just double checking to
Yeah,
make
yeah.
sure. Let H and C come out, then I distribute the 2F times that, and then times that. All right, I think my signs are now correct.
Okay.
So mv squared equals h squared over c squared times, I got 2f initial squareds plus 2f initial delta f plus delta f squared minus 2f initial squared cosine of theta. Actually, I'm going to keep that. Plus 2f initial delta f cosine of theta. Let's make sure that works. So the second part I just kept as is. In this first part here, I have delta F squared. So as light comes in, it gives off some of its energy, and then it comes out as a smaller frequency. If it's a small change, and I'm going to hand wave that justification, but if delta F is small, I'm not saying much less than 1, but it's not necessarily much less than 1 if F is, a billion. If the change in frequency is small, then this term right here is going to be practically 0. It's a fraction of a fraction. But in reality, as long as, there we go. If delta F is much less than F, my initial frequency, then delta F squared is irrelevant. And so that leaves me with mv squared is equal to h squared over c squared times, oh, well, at this point, I can factor 2fi out to, wait, oh no, I want the 2 out. Yeah, I want the fi too, also. 2fi, and I'm left with fi plus delta f minus, here, if I take out the 2fi, I'm left with fi plus 2 delta f cosine theta. That 2 should not be there. That 2. I can factor it one step further. So the momentum of the electron final is equal to 2h squared F initial over C squared times my initial frequency of the light plus whatever the change in frequency is times 1 minus cosine theta.
So we just got rid of the delta F squared because it's close enough to zero.
Yeah. Officially, this is closer to what happens. If I've got 2fi squared plus 2fi delta f plus delta f squared. If I factor fi out, it'd be fi times 2fi plus 2 delta f plus delta f squared over f. Actually, change that. If I factor fi squared out, I'm left with 2 plus 2 delta f over fi plus delta f over fi squared. As long as delta f is much less than fi, this second term drops out. And then if I send factor 2 out and send an fi in, you get to that. That's more efficiently what happens. All right, I'll make this disappear. I'm going to divide both sides by 2. So I have m squared v squared, and I can probably do it in a color more visible. M squared v squared over 2 equals h squared f sub I over c squared fi plus delta f 1 minus cosine theta. All right, so conservation of momentum gets us to there. Now let's take a look at conservation of energy. So this is all the initial equals the final. Now E initial equals E final. There, all right, not a vector. So my total, my electron just sitting there. We're not dealing with any potential energies of any note here. So my total energy beforehand is just the energy of the light. So I have energy of the light initial, and that's got to be equal to the energy of the light final plus the energy of the electron final. Technically, energy of the electron initial plus that, but that is zero. This is just conservation of energy. The force between the light and the electron are electromagnetic forces, which are conservative. Energy is conservative. Energy of the light is going to be H times F initial is equal to H times F final plus, well, if we're not dealing with potential energy, what's left?
Kinetic?
And what's the formula for kinetic energy? All right, 3, 2, 1.
1/2.
No. V squared.
There we, as a group, we got it.
Okay. Yay!
Yay!
Sorry.
Remember what I said, though?
No, probably not. Oh boy.
If I subtract F final from both sides, I get H F initial minus H F final equals 1/2 mv squared. And as talked about earlier, that mass is the mass of the electron. That speed is the speed of the electron. I just not writing the subscripts because I'm feeling lazy. Final speed of the electron. The left-hand side of the equation, to factor H out, I get H of F initial minus F final. And I can sometimes do an F properly, F final. And what is F initial minus F final?
Delta F.
So close.
Wait.
Change is final minus initial.
Right.
So initial minus final is,
The inverse change.
yeah, the additive inverse, or the negative. So that's negative H delta F. So we are now left with 1/2 mv squared is equal to negative H delta F. One half mv squared equals negative H delta F. If I multiply both sides by the mass of the electron, I get 1/2 m squared v squared is equal to negative m H delta F. That 1/2 m squared v squared we have on the other screen. Right there. Assuming I can memorize this H. All right, we'll see how well that does. So I have negative m H delta F equals H squared F initial over C squared times F initial plus. Lost it already. F what?
Delta F, and then 1 minus.
So this right here, this line right there is my initial energy equals my final energy. We can get rid of an H. If we divide both sides by H, that H cancels out with one of those. And let's see, I'm gonna keep that on the frequencies. Remember, all right, so I'm getting all the frequency terms on one side, the non-frequencies on the other. Okay. And I stick the negative sign, I leave the negative on one side. All right, so I'm gonna divide by m. So I bring m over to the other side. That negative delta F equals HF initial over MC squared. F initial plus delta F. 1 minus cosine theta. I'm going to take the two remaining F terms that I have on the right side, move them over to the left. So in other words, I'm taking that and dividing both sides by it, taking that and dividing both sides by it. So I have negative delta F over Fi plus delta F equals H over MC squared, 1 minus cosine theta. Quick check. Not quite sure why I did that step there, but I did anyway. Oh, I know why I did that step. I'm gonna multiply both sides by C, just one of them. Negative C delta F over Fi plus delta F equals H over MC 1 minus cosine of theta. And if you're wondering why you did that, hopefully it'll become a little bit clearer. It's going to make things a little bit simpler in the final step. At least I'm not going through the derivation of something which turns out to be wrong. So, like the classical prediction of the energy distribution of the black body. All right, so I'm going to take this, and I want you to flash back to the golden years of algebra 1, 2, or whatever they call it nowadays. We have this. I want to break that up into the sum of fractions. If I have delta f over f sub i plus delta f, I'm making the claim that this is equal to some number over f sub I plus some other number over f sub I plus delta f. So if I multiply everything by the LCD, I get delta F is equal to A Fi plus delta F plus B times Fi. So delta F is equal to A Fi plus A delta F plus B Fi. Delta F is equal to A delta F plus A plus B. So a combination of A and B that would work, if I think of F delta F and Fi as sort of separate entities at the moment, well, it works if A is equal to 1, because then because I have 1 delta F over here, and I need 1 delta F over here. I don't have any Fi's over on the left-hand side, so A plus B must be equal to 0. So A plus B equals 0. I know A is 1, so B must be negative 1. So I'm making the claim that delta F over that is the same as 1 over F sub I minus 1 over F sub I plus delta F. And so if you work backwards, if you went to try to get this as a common fraction, you have Fi plus delta F over Fi minus Fi over Fi times F. And the Fi's would cancel out, and we'd be left with delta F. It works. So I had negative C delta F over Fi plus delta F equals H over MC 1 minus cosine of theta. I think that's what I had. Yeah, okay. The left-hand side would be negative C over F sub I minus plus c over fi plus delta f equals h over mc 1 minus cosine of theta. If we flash back to whenever we started this, I know that the speed of light is equal to the frequency times the wavelength. Therefore, the frequency is equal to the speed over the wavelength. Or that's not the way I want it. Then I know that the wavelength is equal to c divided by the frequency. Hey, I've got c over frequency here. So this becomes negative the initial wavelength plus, well, fi plus delta f is just my final frequency. So this becomes plus lambda, my final wavelength, is equal to h over mc, 1 minus cosine of theta. On the left-hand side here, well, that's just final minus the initial, or for the pedantics, negative initial plus the final, which is just the change in the wavelength. So after all of that, we end up with this prediction that if I shoot light at a target where I can eject an electron, then I can predict what the wavelength of light is afterwards based upon the angle at which the light shoots off. Notice that the speed of the electron has disappeared from our equation. It's sort of built into the theta here. So we have that the change in the wavelength from the light is equal to h over mc, 1 minus cosine theta. And so I set up my detector. I get my my target. I shoot light at my target. I put my detector here, and I measure the wavelength of light that goes shooting off at that angle. Then I move to a different angle, detect the wavelength of light coming off.